Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for October-November 2017 variant 1. So let's get started. Question 1 says a student measures the volume of a cork. He puts some water into a measuring cylinder and then one glass bowl. He puts the cork and then a second identical glass bowl into the water as shown. Diagram 1 shows the first water level. Diagram 2 shows the water level after one glass bowl is added. Diagram 3 shows the water level after the cork and the second glass bowl are added. What is the volume of the cork? So the volume of one bowl is equal to the difference between 60 here and 50. So we calculate 60 minus 50, that gives us 10 centimeter cubed. Then we calculate the difference between 160, that gives us the volume of the bowls and the cork. So 100 minus 60, that gives us a total volume of 40, but we only added one bowl and the cork, and one bowl is equal to 10. So the 40 is equal to 10, which is one bowl, and the volume of the cork. So the volume of the cork is equal to 40 minus 10. So the answer here is 30 centimeter cubed. So we choose A. Question 2 says 4 balls with different masses are dropped from the heights shown. Air resistance may be ignored. Which ball has the smallest average speed? So the smallest average speed for constant acceleration would happen when there is a smallest final velocity, because the average velocity can be calculated as final plus initial over 2, the average of initial and final, and the initial was 0. So the smallest average would be having the smallest final velocity, which means there was not enough time to accelerate. So falling the smallest distance will give us the smallest final velocity and smallest average velocity. So the answer here is A. Question 3 says an ice crystal falls vertically from a cloud. What happens to the acceleration of the ice crystal as it falls? It is either decreasing due to air resistance or constant due to gravity, so it is not increasing. So it decreases because of air resistance, yes, not due to gravity. So the answer is A. Question 4 says a spring is stretched by hanging a piece of metal from it. Which name is given to the force that stretches the spring? It is the weight of the block. So the weight is the answer. So choose D. Question 5 says which object has the greatest weight? An object of mass 10 kilograms in a field strength 15 newtons per kilogram. So we multiply 10 by 15, that gives us 150 newtons. Then 15 by 13, that gives us 195 newtons, which is greater. Then we have 20 times 9, that gives us 180, smaller. 50 times 3, that gives us 150 again. So the answer is B with the greatest number. Question 6 says a uniform beam XY is 100 centimeters long. That means that the weight is at the center of the beam and is equal to 4 newtons. At this point, the beam rests on a pivot 60 centimeters from end X. A load of 8 newtons hangs from the beam 10 centimeters from end X. The beam is kept balanced by a force F acting on the beam 80 centimeters from end X. What is the magnitude of force F? So if it is resting, it means it's in equilibrium. So clockwise moments are equal to the anti-clockwise moments. And the clockwise moment is caused by the force F at a distance of the difference between 80 and 60, that's 20. And we have the anti-clockwise moment, we have 4 newtons at a distance here from the middle, which is 50, to the pivot, which is at 60, that would be 10 centimeters. And the distance between the 8 Newton load and the pivot is equal to the difference between 60 and 10. So this distance is 50. So clockwise moment, force times the distance 20 is equal to the sum of two moments. We have the force 4 Newton multiplied by the distance 10 plus the force 8 multiplied by the distance 50, and then we divide by 20 on the other side. That would give us an answer of 22 newtons. So the answer is C. Question 7 says the diagrams show 4 table lamps resting on a table. The position of the center of mass of each lamp is labeled X. Which lamp is the most stable? So we need a low center of gravity, so A and C are rejected, and the wide base area, so this is the widest one, so we choose B. Question 8 says the diagram shows an incomplete scale drawing to find the resultant of two 10 Newton forces acting at a point in the directions shown. What is the magnitude of the resultant force? The resultant force would be pointing from this point to the other opposite point. So this is the resultant. It appears to be longer than 10 newtons. So anything less than 10 newtons is rejected. And it cannot be 20 newtons because that would happen if the forces are parallel in the same direction. 10 and 10, that would give us addition of 20, so it is not 20, so the answer must be 18. Question 9 says a tennis ball of mass 0.060 kilograms travels horizontally at a speed of 25 meters per second. The ball hits a tennis racket and rebounds horizontally at a speed of 40 meters per second. The ball is in contact with the racket for 50 milliseconds. What force does the racket exert on the ball? So we can use the equation force is equal to the change in momentum over time, or mass multiplied by the change in velocity over time. Then we substitute. The mass is 0.060 and the velocities are final 40 minus the initial would be negative 25 because they have opposite directions, and then we divide by the time. 50 times 10 to the power of negative 3 for milliseconds. That gives us an answer of 78 newtons, so we choose D. Question 10 says the diagram shows the path of a stone that is thrown from X and reaches its maximum height at Y. The stone gains 10 joules of gravitational potential energy as it moves from X to Y. The stone has 2 joules of kinetic energy at Y. Air resistance can be ignored. How much kinetic energy did the stone have immediately after it was thrown at X? So we can use the conservation of energy. Gravitational potential energy initial plus kinetic energy initial is equal to gravitational potential energy final plus kinetic energy final plus losses or wasted energy. And wasted energy is 0 because the air resistance is ignored. Kinetic energy final was 2 joules. The gravitational potential energy final was 10 joules. And the initial kinetic energy is unknown. The initial gravitational potential energy at the ground level is 0. So the kinetic energy initial is equal to 10 plus 2, which is 12, so we choose D. Question 11 says a motor is used to lift a load of 40 newtons. The power of the motor is 40 watt and the system is 20% efficient. How long does it take the motor to lift the load through a distance of 0.50 meters? So first we can calculate the output power, which is equal to 20% out of the 40 watts. That gives us an answer of 8 watts, and then we can use the equation power is equal to work done over time or force multiplied by distance over time. So the time would replace the power, and we have time is equal to force times distance over power. So we have 40 newtons multiplied by the distance 0.5, and then we divide by the power 8. That gives an answer of 2.5 seconds, so we choose B. Question 12 says a student runs up a flight of stairs. Which information is not needed to calculate the rate at which the student is doing work against gravity? So rate means time, work done, which is force multiplied by the parallel distance, but gravity is vertically down, so we need vertical amounts. Weight is vertical force, height is vertical distance, but the length of the stairs is inclined, so it is not vertical, so it would be the length of the flight of stairs, not the height. The length is unnecessary, so we choose B. Question 13 is about barometers, so you can skip this for the new syllabus. The diagram shows a simple mercury barometer. Which length is used to find the value of atmospheric pressure? So it is from the surface of the mercury in the dish, which is at 12 here, to the surface of the mercury in the tube, which is at 86. So we subtract 86 minus 12. That gives us an answer of 74 centimeters, so we choose B. Question 14 says the diagram shows a glass flask sealed with a small volume of mercury in a glass tube. When the flask is gently warmed, the mercury rises up the tube. What is the main cause of the movement of the mercury? So if we are heating from the bottom, the water is getting heated and the air above it is getting heated, and the air is what pushes the mercury. So it is the expansion of the air in the flask, yes, not the expansion of the glass flask. That would cause the mercury to drop down. Expansion of glass tube, no, again that would cause the mercury to drop. Expansion of mercury, no, because we are heating the glass tube first, so we choose A. Question 15 says a pollen grain in a beaker of still water is viewed through a microscope. Which diagram shows the most likely movement of the pollen grain? It must be random broken lines, so it mustn't have a pattern, so we choose A. And it is not curved, so it is not C or D. Question 16 says the diagram shows an air-filled rubber toy. A child sits on the toy and its volume decreases. The temperature of the air in the toy does not change. How does the air pressure in the toy change? So when volume decreases, the pressure increases. That is because the molecules do not move more slowly or more quickly. It is because the air molecules strike the rubber more frequently, not less frequently. So the choice here is D. Question 17 says a strip of iron and a strip of brass are firmly attached to each other along their entire length. This combination is a bimetallic strip. This bimetallic strip is heated and it bends as shown. So the brass has a longer length now than the iron, shown by the diagram on the bottom. So the bimetallic strip is now cooled and becomes straight again. Whichever expands more also contracts more. So in cooled we contract. What causes the bimetallic strip to become straight again? Brass contracts more than iron. That is correct. Brass expands more than iron. That's correct, but not related to this sentence, which is cooling. That would be contracting, not expanding. The iron contracts more than the brass. Expands more than the brass. No, because the diagram shows that it expands less, so it also contracts less. So the answer here is A. Question 18 says an aluminium block has a mass of 200 grams. The specific heat capacity of aluminium is 900 joules per kilogram degrees Celsius. How much energy is needed to raise the temperature of the block from 20 degrees Celsius to 110 degrees Celsius? So we use the equation energy is equal to mc delta theta. So the mass is equal to 200 grams, but the unit for specific heat capacity is in kilograms. So we divide by 1000, so 0.200. Multiplied by 900 and then multiplied by 110 minus 20. That gives an answer of 16,200 joules, so we choose C. Question 19 says which statement about convection currents is correct? Convection currents occur because when cooled, liquids contract and become more dense. That is correct. Not expand and become more dense when warmed. Convection currents only occur in liquids. No, they also occur in gases. Convection currents only occur in solids and liquids. No, they do not occur in solids. So the answer here is A. Question 20 says a diagram represents plane wavefronts of a water wave about to strike a solid barrier. Which diagram shows the position of the wavefronts after reflection at the barrier? So this is the direction of the original wave. At this point we can draw a normal and we draw a reflected ray at the same angle. So this is the direction of the reflected wave and the wavefronts will be perpendicular to the new direction. And we check the diagrams here, not A, not B. It is C, the same as the one we've done. Question 21 says the diagram shows an object in front of a plane mirror. A ray of light from the object is incident on the mirror. Through which point does the reflected ray pass and at which point is the image of the object formed? So the image of an object in a plane mirror is always right in front of the object at the same distance, so it is R. So the point of the image is R. And the ray reflects from this point, so this is a normal. If we calculate the angle here and here, the reflected ray will pass through point P. So these are the choices, and the common one here is A. Question 22 says a laser is a source of light with a single frequency. Which description of this type of light is correct? So a single frequency, that's a monochromatic light, so we choose C. Question 23 says visible light, X-rays, and microwaves are all components of the electromagnetic spectrum. Which statement about the waves is correct? In a vacuum, microwaves travel faster than visible light. No, they all travel at the same speed. In a vacuum, microwaves travel at the same speed as visible light and have shorter wavelength. No, microwaves have longer wavelength than light. In vacuum, X-rays travel faster. Again, no. Same speed, yes, as visible light and have shorter wavelength. Yes, X-rays are shorter than visible light, so we choose D. Question 24 says the moon is 380,000 kilometers from the Earth. A laser light beam is directed from the Earth to the moon. The beam is reflected back to the Earth. How long does it take for the light to travel to the moon and back to the Earth? So that's like an echo, but for light, that's a reflection of light. So speed is equal to twice the distance over time. So time is equal to twice the distance over the speed. So the distance is equal to 380,000, but to convert from kilometers to meters, we multiply by 1,000 again. Then we divide by the speed of light through vacuum, which is 3 times 10 to the power of 8. This should be known. This gives an answer of approximately 2.53 seconds, so we choose D. Question 25 says which wavefront is traveling at a speed closest to that of a sound wave through a solid? We have distances and time, so we divide the distance by time for each. 10 divided by 0.01, that gives us 1000 meters per second. 50 divided by 0.5, that gives us 100. 1000 divided by 100, that gives us 10. 2000 divided by 2000, that gives us 1. In solids, the sound travels the fastest, so we choose the thousands here. So the answer is A. Question 26 says different waves travel through air. Which waves have the greatest difference in speed? Ultrasound waves and sound waves, they are the same thing, so they do not have different speeds, they have the same speed. Ultrasound waves and ultraviolet waves, yes, ultrasound waves travel at 340 meters per second approximately, but ultraviolet rays travels with the speed of light, which is 3 times 10 to the power of 8, so this will have the greatest difference. Ultraviolet waves and light waves travel at the same speed, so no different. Ultraviolet waves and radio waves also have the same speed, electromagnetic, so no difference, so we choose B. Question 27 says a student stands 180 meters from a vertical flat cliff and bangs together two pieces of wood to make a short loud sound. A timer records the echo of the sound 1.5 seconds after the pieces of wood are banged together. Based on this result, what is the speed of sound? So for an echo, speed is equal to twice the distance going forward and back over the time. So we have 2 times 180 divided by the time 1.5. That gives an answer of 240 meters per second, so we choose B. Question 28 says a train of steel nails and a train of iron nails hang from a strong magnet. The trains are then carefully removed from the magnet. What happens to the trains? So steel is a hard magnetic material which retains its magnetization, so they will still be attached. But iron is a soft magnetic material, so they will fall apart. So both trains fall apart? No. Both trains stay together? No. Only train of iron falls apart? Yes. Not steel because it's hard magnetic material, so we choose C. Question 29 says, how can a permanent magnet be demagnetized? Cool the magnet? No. Place it next to another magnet? No. Slowly pull it out of a coil connected to an AC supply? Yes. So the answer is C. Question 30 says a positively charged rod is held near to but not touching an uncharged metal sphere. The sphere is briefly now connected to Earth. So these are the steps for charging by induction. Which statement about the charge on the sphere is correct? If we use a positively charged object to charge a metal by induction, we receive a negative charge at the end. So not positively charged, it is negatively charged, because negative charges have moved from the Earth to the sphere, or positive charges moved. Positive charges do not move, so the answer here is A. Question 31 says the diagram shows a circuit with a gap between points P and Q. 4 pieces of metal wire of the same material are connected in turn between points P and Q in the circuit. The table gives the diameters and length of the wires. In which wire is the current largest? So we need the smallest resistance. So the widest area and the shortest length. So we choose C. Question 32 says a torch has a simple circuit with a 3-volt battery and a lamp. There is a 20 milliampere current in the lamp. How much energy is transferred to the lamp in 5 minutes? So energy is equal to VIT, so we multiply the voltage 3 by the current 20 milli times 10 to the power of negative 3. Then you multiply by the time, which is 5 minutes, but to convert it to seconds, we multiply by 60. That gives an answer of 18 joules, so we choose B. Question 33 says a student connects the circuit shown. Which graph shows the variation with time of the current in the resistor? So we have one diode here, which causes half wave rectification. So we choose B, where the current flows in one direction, then it is 0 when the voltage is reversed, and then repeats. Question 34 says the diagram shows a circuit with a fixed resistor connected in series with a thermistor and an ammeter. Which row shows how the temperature change affects the resistance of the thermistor and the current in the circuit? So the temperature, as it increases, the resistance decreases and vice versa. So if both decrease or both increase, it's wrong. So decreases and increases, yes. Increases and decreases, yes. And the resistance is inversely proportional to the current. If the resistance increases, the current decreases, not the same thing. So the answer here is B. Question 35 is about logic gates, so you can skip this question for the new syllabus. It says, what does the symbol shown represent? This is an AND gate, so we choose A. Question 36 says the diagram shows a copper wire XY connected to a resistor. The wire is moved in the magnetic field between the poles of a magnet. There is an induced current from X to Y, so this is out of the page. The current here is out of the page, and the magnetic field is to the right. In which label direction is the wire moving? So using the right hand rule for electromagnetic induction, if the field is to the right, the index finger pointing to the right, and the current is out of the page, the middle finger pointing out of the page, the thumb will be pointing downwards. Make sure you are using your right hand, not your left hand. So the choice here is D. Question 37 says the graph shows how the voltage induced across a coil changes with time as the coil spins in a magnetic field. Which graph shows what happens when the coil spins more quickly? So the voltage increases and the time is shorter, or the number of cycles increases. So that would be C, with greater amplitude and shorter periodic time. Question 38 says emissions X and Y from radioactive material are passed through a magnetic field. The diagram shows the direction of emissions, the direction of the magnetic field, and the effect on the emissions. Which type of emission is X and which type of emission is Y? So X and Y have opposite deflections, that's positive and negative charges, so alpha and beta. So no gamma rays, they would not be deflected by the magnetic field at all. And alpha particles have small deflection, beta particles have large deflection. So X is alpha particle and Y is beta. So the answer here is A. Question 39 says, what is meant by the half-life of a radioactive isotope? It is not half of the time, it is the time taken for half of the original nuclei to decay, or charges on the nuclei to half, or mass of each nucleus to half. No, not the mass of each nucleus, and no charges. It is half the original nuclei to decay, so choose B. Question 40 says the rate of emission of radioactive source is measured until the reading reaches background rate of 20 counts per minute. So we have background here and the results are shown. What is the best estimate for the half-life of the source? We have the initial value here 200, but when there is background we need to subtract the background at first. So 200 minus 20, that gives us 180. Then we divide that by 2 for one half-life, that gives us 90. But to move back to the graph with the background, we need to add the background again. So 90 plus 20, that gives us 110. Then we use this value to get the half-life from the x-axis. So going down from this point here, it is pointing towards the 10-minute. So the answer here is A. So this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing, and I will see you in another video.